Welcome to The Debate. 3 seconds from now, you are going to make a completely spontaneous decision.
Or at least it'll feel spontaneous, right?
Exactly. I mean, maybe you'll veer toward a familiar street food stall in Manila for an impulsive snack. Or perhaps you're sitting at a trading terminal in Frankfurt about to execute a really calculated stock trade. To you, in your own mind, that decision feels entirely autonomous.
It feels like free will.
Right, it feels like free will, born in the exact millisecond you execute it. But what if a server on the other side of the planet knew you were going to do it, say 3 days ago?
And that invisible foresight, that's what really brings us to a profound crossroads today. We are looking at a global, highly interconnected apparatus that basically maps and predicts human action at an unprecedented scale.
It really is staggering.
It is. And the fundamental question we have to grapple with on the show today is whether this granular behavioral monitoring fundamentally violates individual human autonomy. Put simply, does the monumental technological convenience of predictive AI outweigh the risks, the severe existential risks of constant invisible surveillance on citizens?
Well, my perspective on this is that these predictive AI systems ultimately optimize human agency and really societal functions as a whole. I strongly believe they provide profound convenience and undeniable public good without inherently destroying individual free will.
And I take a highly skeptical stance here. My position is that the relentless extraction and clustering of what I call our behavioral genomes constitutes an unprecedented surveillance apparatus. It fundamentally threatens individual autonomy through subtle, pervasive manipulation.
Okay, well, let's start by unpacking what is actually happening under the hood, because I think, demystifying the technology removes a lot of the dystopian dread that usually surrounds this topic.
Sure, lay it out for us.
What we are really talking about is just a deterministic lens. It distills pure human chaos into manageable probabilities.
Right. But let's be really clear about what that deterministic lens actually requires to function. I mean, it requires an absolute avalanche of intimate data.
It does. Absolutely. The prediction pipelines begin with what data scientists call feature engineering. They take historical actions like your click logs on a website, the timestamps of your recent purchases, the GPS location trails from your phone.
The digital breadcrumbs.
Exactly, the breadcrumbs, and they form a backbone of data. So if you have a sequence of morning jogs in the parks of Sydney, the system mathematically predicts a weekend trail run. If there are erratic late-night snack purchases in Mexico City, the system recognizes a pattern of stress eating.
Right.
It just uses algorithms to weigh your recent events heavier than your past ones. It's not magic, and it's certainly not mind control. It is simply processing sheer volume to predict an outcome.
I come at it from a very different way, honestly, because calling it processing volume really glosses over the reality of what is actually an invasive dissection of the human psyche.
Oh, invasive dissection is a bit strong, don't you think?
I don't think so at all. We aren't just talking about a system counting how many cars are on a road. The depth of this monitoring is staggering. Let me give you an example. AI doesn't just track locations anymore. It measures keystroke dynamics in Tokyo offices.
Wait, you mean the physical speed of how someone types?
Exactly. It measures the exact milliseconds between keystrokes to detect an employee's level of urgency or even anxiety. Or look at what happens on smartphones. The systems analyze swipe entropy in Istanbul.
Swipe entropy?
Yeah, so when someone is shopping on their phone, the AI measures the erratic paths of the shopper's finger on the glass screen. It actually quantifies their level of impulsivity in real time. It extracts voice prosody from a phone call, noticing the flat tones of reserved Scandinavian queries or the rising inflections in Brazilian business negotiations.
But again, that's just data collection. That's observation.
It goes so far beyond observation when you build what I called earlier a behavioral genome. Just like your biological genome dictates your physical traits, this digital genome maps your psychological vulnerabilities.
Okay, but how does mapping a vulnerability translate to losing autonomy?
Because when a system maps all of these incredibly intimate physical behaviors into complex mathematical categories, You aren't just building a traffic alert system, you are building behavioral archetypes. And once a system categorizes you as, say, an impulsive buyer based on swipe entropy, it allows other systems to prey on those vulnerabilities.
You're talking about targeted marketing.
It's darker than that. We see this with dark patterns exploiting habitual scrollers or manipulative gambling apps hooking vulnerable users in Macau. This constant surveillance doesn't just observe, it actively chills expression and strips away individual autonomy by exploiting exactly how our brains are wired.
Well, we have to remember that under the hood, this isn't coercion, it's just probability. The system uses algorithms to essentially build a massive, complex decision tree of your life. When a system wants to predict a choice, it uses things like random forests.
Let's pause and explain what a random forest actually is doing in this context, because to the average listener, that sounds like pretty harmless math.
That's fair. So think of a single decision tree like a flowchart for your day. At every branch, the AI asks a question, like, is it raining? Is it a Tuesday? Did the user sleep poorly?
Basically a giant game of guess who.
Right, and a random forest is basically the AI looking at thousands of these branching yes or no flowcharts all at once to find the most common outcome. By looking at all these branches, it groups your behaviors together. And at the end of those branches, all it does is rank the likelihood of an action.
It spits out a percentage.
Yes, it gives us an interpretable forecast. It looks at the data and says, hey, it's raining in Seattle, and this user's alarm went off late. There's an 80% chance they're going to buy a coffee.
But an 80% chance isn't a guarantee, right? Which means the commercial model has a massive financial incentive to push you toward that 100% certainty.
I'm not convinced by that line of reasoning, honestly, because the model itself isn't forcing your hand. I think of it like meteorology. A meteorologist predicting a rainstorm doesn't mean the meteorologist is controlling the rain.
But
Let me just finish the thought. Humans still make the final choice to walk into the cafe and buy the coffee. The algorithms are simply mapping what Charles Duhigg calls habit loops. You know, the cycle of a cue, a routine, and a reward.
the alarm clock being the cue.
Exactly. If a morning alarm cues the routine of buying coffee for habitual drinkers in Brazil, the AI merely notes it. If the system uses hazard models to calculate the exact timeline of when you're likely to make your next purchase, it's just measuring the natural decay of your current satisfaction. It is observation, not active intervention. Humans retain their agency.
I'm sorry, but I just don't buy that. Let me tell you why the meteorologist analogy falls completely apart.
Okay, go ahead.
The weather doesn't change its behavior because it read the forecast, but human beings do. And more importantly, the digital environments we inhabit actively change around us based on that forecast. This is not passive observation. AI systems actively intervene to shape the outcome.
How so? Give me the specific mechanism.
Consider generative adversarial networks, or GANs. These are AI systems that essentially pit two neural networks against each other to generate incredibly realistic simulations. They don't just predict, they simulate counterfactuals.
Right, the what-if scenarios.
Exactly. They run millions of scenarios asking, what if traffic worsens for this specific driver in São Paulo? And then the system adjusts the digital environment, like sending a perfectly timed notification, to actively alter the driver's route, or take multi-agent reinforcement learning.
Right, where the AI plays out millions of simulation games.
Yes. It pits simulated versions of ourselves against digital environments to figure out the perfect sequence of nudges to maximize spending, like crafting the perfect grocery delivery interface for thrifty Eastern European markets.
But again, that's just UI optimization.
It's more than that. When someone abandons a pair of sneakers in a digital shopping cart in Berlin, and the system immediately triggers a targeted, time-sensitive discount, that is an active intervention. The AI calculated the exact millisecond your willpower was fading. It deliberately leverages behavioral science, specifically prospect theory and loss aversion.
Meaning our psychological fear of losing out on a deal.
Precisely. We see this incredibly clearly in Dubai trading markets. Algorithms monitor a trader's behavior, and they know exactly how to trigger loss aversion to make them cling to a losing trade. It isn't just watching you trade, it's designing the interface to actively bend your human agency to serve a commercial outcome.
I see why you think that. But let me give you a different perspective on what those interventions actually achieve at a macro level. Yes, the system nudges. Yes, there are commercial applications. But we have to weigh that against the monumental public good that these exact same predictive pipelines enable.
Are you arguing the convenience justifies the manipulation?
I'm arguing that the optimization saves lives. Think about how epidemiologists use these exact same mobility behaviors to model outbreak trajectories in dense Asian cities. That requires analyzing the aggregate behavior of millions of people.
I'm not denying the utility of epidemiology.
But it's the exact same tech. Think about urban planners optimizing crowd flows based on pedestrian heat maps in Rome's squares to prevent stampedes, or agriculture AI advising farmers in Kenyan fields based on their daily routines and local weather patterns. The scale of the benefit is massive. We get preemptive traffic alerts in Mexico City that literally save countless hours of human life every year.
But the cost of that traffic alert is giving a centralized system access to your exact movements every single day, forever.
And that's where I would push back, because the field has developed incredibly robust, privacy-preserving techniques. Society can reap the immense benefits of AI without exposing the individual to the kind of dystopian surveillance you're describing.
How exactly? Because anytime data is collected, it is vulnerable to exposure.
Let's look at the mechanism. Data scientists use something called differential noise. Imagine you want to know the average age of a crowd of people, but nobody wants to reveal their exact age. So, you tell everyone to flip a coin.
Okay, I'm following.
If it's heads, tell me your real age. If it's tails, tell me a completely random number. When I collect all the answers, I can't know anyone's true age. The individual is cloaked by the random noise. But because I know the statistical probability of the coin flips, I can still calculate the exact average age of the crowd. The societal trend is perfectly visible, but your specific actions remain totally hidden.
That works beautifully in a vacuum, sure.
Well, we also use federated learning paradigms. Instead of your phone sending all its raw personal data to a central server in Frankfurt, the AI model is actually trained locally, right on your physical device.
To sending the math back.
Exactly. Only the updated mathematical weights, the abstract lessons the AI learned, not your personal photos or text messages, are sent to the cloud. Society gets the smarter model, and you keep your privacy.
Look, those privacy shields sound incredibly comforting in theory. I'll fully admit the math behind differential noise is elegant, but in practice, they are fundamentally porous when faced with what we call multimodal fusion.
Meaning the AI combining different senses, right? Like sight and sound?
Yes. You can add all the differential noise you want to my location data, but these systems are integrating senses across multiple streams simultaneously. They use Kalman filters. In engineering, a Kalman filter is a way to blend a bunch of noisy, uncertain signals together to accurately predict a true state.
Right, filtering out the noise to find the signal.
Exactly. So the AI isn't just looking at your noisy location data. It pairs computer vision that decodes facial microexpressions down to the furrowed brows of an indecisive fashionista in Paris with natural language processing that maps the escalating frustration in a customer support chat.
Wait, so you're saying the sheer variety of data points overrides the privacy protections on any single data point?
Exactly. When you fuse sensor data with autoencoders, which are neural networks designed to compress data and flag anomalies, like irregular sleep patterns in a jet-lagged traveler, you weave an inescapable web. The privacy protections are completely circumvented by the sheer dimensionality of the data.
So the noise doesn't matter anymore?
No! If I blur your face, but I know your heartbeat, your typing speed, and your vocal inflection, I still know exactly who you are and what you're feeling.
That's an interesting point, though. I would frame it differently. Even if the data is highly dimensional, it doesn't automatically mean it's weaponized against you.
But the societal benefits you mention are heavily overshadowed by the risks. In monitored regimes, this level of surveillance actively chills expression. And there is a fundamental flaw in the math itself. Because these models require massive, uniform data, they inherently carry biases that mismodel understudied populations.
You mean the models just assume everyone acts like the majority of the data set?
Right. When the behaviors of indigenous communities in Amazonia are misrepresented because the global models are heavily skewed toward Western consumer actions, that's not just a mathematical error, it is an entrenchment of inequity. The system forces a rigid template onto human behavior.
I see that, but
Let me just add, I am not denying that having a behavior-aware tutor for a distracted student in the Philippines is highly convenient. I am arguing that this convenience shouldn't cost us our fundamental right to an unmonitored existence.
But your argument assumes we are entirely passive subjects, completely stripped of all agency. And that simply isn't the case. Human agency remains intact precisely because we have defensive mechanisms, both structural and personal.
I mean, what kind of structural defenses actually stand a chance against algorithms processing petabytes of data?
Well, structurally, we are seeing major regulatory shifts. Look at China's Personal Information Protection Law, or PIPL. It specifically curbs algorithmic misuse and legally limits how behavioral data can be leveraged for price discrimination.
Regulation is notoriously slow.
True, but we also have the rise of explainable AI tools. These are systems specifically designed to let users and regulators audit predictions. They expose the mathematical logic behind a targeted ad or a behavioral nudge, so the black box is finally broken open.
Regulation is always 5 steps behind the technology, though.
Perhaps, but on a personal level, humans are incredibly adaptable. We can actively diversify our behaviors to evade models.
You mean trying to purposefully confuse the algorithm?
Exactly. If you know a system is mapping your routine, you can consciously change it. The very fact that individuals can purposefully alter their digital footprint to introduce noise into their own data proves that algorithmic determinism hasn't entirely won. If a model expects you to turn left, you can decide to turn right. The probabilistic engine only works if we remain static and predictable.
That's a compelling argument, but have you considered how deeply impractical it is to actually evade these models today? We aren't just talking about clearing your browser cookies or taking a different physical route to work.
It's more complex now, sure.
It's nearly impossible. How do you evade a model when the IoT, the Internet of Things, sensors in a smart home in Singapore can predict your shopping needs just from the micro fluctuations in the fridge door opening?
You're saying the environment itself is just too saturated to avoid?
We are completely enveloped. How do you diversify your behavior when telecom records in Italy are mapping the proximity pings of your family's cell phones during dinner to predict your social dynamics? You can't just stop eating with your family. And worse, we are relying on systems that are actually surprisingly fragile.
Fragile? Wait, in what sense? You just argued they were basically omnipotent.
Omnipotent in their reach, absolutely, but fragile in their logic. These models overfit to noise. They fail spectacularly during black swan events. Look at how global pandemics disrupted routines worldwide and completely broke supply chain prediction algorithms.
Well, a pandemic is a pretty extreme outlier.
True, but because we've built our entire global infrastructure around their so-called convenience, we are forced to conform to their expectations to keep society running. We are squeezed into these predefined archetypes so that ad tech companies can auction off our behavioral slots.
You're talking about programmatic advertising now?
It's deeper than just ads. They are literally analyzing the duration of a specific commute in Mumbai, identifying the exact 5-minute window where a user's focus peaks, and selling that cognitive real estate to the highest bidder for trillions of dollars globally. This isn't about the model serving the individual. It's about the individual being molded to serve the model's profitability.
It is absolutely true that there is a massive economy built on this predictability. And honestly, the math required to sustain it is breathtakingly sophisticated. I think we have to acknowledge the sheer scale of the engineering here. We're talking about transformer models with self-attention mechanisms.
Right, and for the listener, self-attention is basically what makes systems like modern chatbots so fluent.
Exactly. Self-attention just means the system can weigh the relevance of your entire history all at once. It's not just looking at your last action in isolation. If you search for nearby tacos in Los Angeles, the transformer attends strongly to your past Mexican food logs, your travel patterns, your typical lunch hour, while completely ignoring your unrelated salad purchases.
It prioritizes what matters.
Right. It acts like an incredibly intuitive autocomplete for your whole life. It is processing petabytes of data through distributed systems like Apache Spark,
just to make that one connection.
Look, the mathematical sophistication is undeniable. I will certainly agree with you there. From TensorFlow serving inferences right at the edge, running algorithms locally on offline phones in Siberia, to massive cloud clusters in the US, the engineering is a total marvel.
Right, and to me, where we ultimately land is how we view the function of this massive architecture. Whether we are talking about algorithms modeling the transition from post-grocery comm to recipe searches in India, or neural networks capturing the sequential dependencies of a Tokyo commute, the ultimate function is to harmonize global chaos into actionable convenience.
But it will cost.
Well, yes, it requires a pervasive pipeline, but when properly regulated and transparent, it prevents accidents, reduces waste, allocates resources efficiently, and makes the modern world fundamentally functional.
But again, at what profound cost to us? Translating human quirks, the hesitations in our fingers, the typing rhythms on our keyboards, the tone of our voices, into quantifiable traits for clustering and anomaly detection builds an inescapable behavioral genome. The convenience we get in return, the preemptive traffic alert, the optimized energy grid, is merely a byproduct.
A pretty significant byproduct.
But the core architecture is one of massive, autonomy-eroding surveillance. We are allowing our free will to be parsed by reinforcement signals, ultimately turning human nature into a predictable, manageable, and profitable commodity.
Well, it seems we both agree that global data collection and these incredibly complex predictive pipelines are now inextricably woven into modern human existence. The technology is here, and whether we like it or not, it is observing us.
That much is certain.
As we close today, the core question comes back to how you choose to look at that deterministic lens. Are we the masters of this incredible technological convenience, utilizing our own data to build a safer, more efficient, and highly optimized world?
Or are we, as I suggest, subjects trapped beneath its predictive gaze, our fundamental autonomy chipped away with every keystroke and swipe?
Exactly. There is so much more to explore in this material, particularly around the complex issues of causal inference and how algorithmic bias shapes our daily reality. But deciding whether the convenience compensates for the surveillance, that is a judgment we will have to leave to you, the listener. Thank you for joining us on The Debate.